This is chapter 7, Lewis structures, homework problem 5D. Write Lewis structures for phosphorus hexafluoride, and this is a polyatomic ion, carries one charge. When we count the number of total valence electrons, we have to count this one as well. Okay, so now, let's take a look. Total number of valence electrons. VE means valence electron. Okay, so we have one phosphorus. All right, so we have one phosphorus, and we have a 6 fluorine or fluoride. So then we have that charge, that -1 charge. So that's the total number of electrons. Is that right? Okay, one phosphorus. So that's in group 5A, 5 valence electrons. Each fluorine carries 7 valence electrons because it's in the group 7A. 6 times 7. And then this polyatomic, the charge, polyatomic ion, this charge is -1. That's one more electron. Okay, negative means gain 1 electron. So therefore, if you add all those together, that's actually 5 plus 1, that's 6. And here you already have 7 6, you can say that. So then you have 8 6. 8 times 6, that's 48 electrons. Whatever you work on the calculation. So that should be 48 total electrons, valence. So now let's take a closer look of the polyatomic ion. We have one fluorine, obviously that should be the central atom. Also it's less electronegative than fluorine. Then you have 6 fluorine. Obviously there's bonding between phosphorus and each of the 6 fluoride there. All right, so therefore should be 6 bonds surround phosphorus. Based on that analysis, so phosphorus should be the central atom. We'll draw 6 bonds. 1, 2, 3, 4, 5, 6. And of course, the 6 fluoride, the fluorine, they are the surrounding or peripheral atoms. And when you assign those 48 electrons, of course, each bond already takes 2 electrons, all right? And then the additional one, you will assign them to each of the fluorine atoms with a total number of 8 surrounding each fluorine, all right? So therefore, you place 3 lone pairs plus 1 bonding pair, and that's 2 times 4, 8. 8 for each, okay? And now we have 6. 1, 2, 3, 4, 5, 6 fluorines, then 6. Each has 8. 6 times 8, so that's also 48 electrons, okay? So all 48 electrons is assigned so far. And now, since this is a polyatomic ion, okay, so actually we will learn about the formal charges. So where should that be? Is that around, if this one is around those fluorine atoms, or is around phosphorus? Okay, let's take a look. For each fluorine, 8 electrons surrounding them. That's the electron density, you can say. 8 per atom. But for phosphorus, how many? You have 1 bond, 2, 3, 4, 5, 6 bonding, then 12 electrons. 12 electrons surrounding phosphorus versus 8 electrons surrounding each of the fluorine obviously there's more electron density right here. So therefore, we place that charge, negative charge, right here in the center. Another point I would like to make is we say atoms. So when they form chemical bonds, they should, or even when they exist, as a atom or ion, the octet, they would like to assume the octet structures, all right, 8 electrons. So for each of the fluorine, of course, they have 8 electrons, and that satisfy the octet rule. But for phosphorus, obviously, it does not follow the octet rule, all right? And that's okay. That's called exception of octet rules. So for the central atom, yeah, sometimes it has more than 8, okay? So that's allowed, and that's the most stable one.